So I'd like to do a question number 5 from free response questions non-calculator section, AP Calculus BC of 2022. So figures 1 and 2 shown above illustrate regions in the first quadrant associated with the graphs of y equals 1 over x and y equals 1 over x squared, respectively. In figure 1, let R be the region bounded by the graph of y equals 1 over x, the x-axis, and the vertical lines x equals 1 and x equals 5. In figure 2, let the W be the unbounded region between the graph of y equals 1 over x squared and the axis that lies to the right of the vertical line x equals 3. Find the area of a region R. So the area of region R is shown in the red lines right there. It's pretty straightforward. And because this question is non-calculator part, we just have to find the answer exactly. So x is from 1 to 5, and the equation of the graph is 1 over x, so 1 over dx like that, and that's just ln of x from 1 to 5, ln of 5 minus ln of 1, and in fact ln of 1 is just 0, so ln of 5 exactly. That's the answer for the question A. B, region R is the base of a solid. For the solid, at each x, the cross section perpendicular to the x-axis is a rectangle with the area given by x times e to the x over 5. Find the volume of the solid. So this question is a little tricky because usually when you think of a cross section perpendicular to some axis, say in this case x and y, and the graph is like that, so the perpendicular, so the rectangle is going to be formed like this, I suppose. And usually you think of how long is the base and how long is the height here. But in this question, the area of each rectangle is always already given. So it's just y 1 to 5 x e x over 5 dx. Pretty simple, but you have to take a moment for a second to actually realize that you don't have to take anything. It just use the equation given in a question. Well, as you can see, there are two functions here, x and e to the x over 5. So you might want to use the integration by parts. Let's dissect that. X ex over 5 dx. That will make it 5ex over 5 and just dx. Because in this case, uv equals uv minus like that. The integral is equal to x times 5ex over 5 minus ex over 5 dx. Actually, I forgot 5. Let's make it more simple. Alright. And it's actually, whole thing is from 5 to 1 actually. Alright, so plug in 5 first. Minus and a 1, right? Minus 25e minus 5e 1 to the 1 over 5 times 25e minus 25. No, hold on. That was just plus e1. Okay. Here you can cancel. So the remainder is 20e to the 1 over 5. That's the area exactly. Alright, the final volume of the solid generated when the unbounded region W is revolved about the x-axis. Here again, this is R, and what it means by being bounded is that though the graph is getting really close, approaching to x-axis, it never touches. But if you see the graph really far away, it looks like it's touched. And you revolve so about the x-axis. Now you're gonna have millions of disks piled up to onto each other. That means you're gonna have pi, of course, anything 3 to the infinity, and 1 over x squared because the area of a circle is pi r squared. And we're gonna make sure that we don't really use infinity sign and then instead of integral, so we use b instead as a replacement. We can bring pi in front of limit, and now it's just a simple integration. That would be like that. That will make it b minus plus actually 1 over 3 cubed. We plug b in. We plug b here. We plug infinity into b here. It's gonna make it really small, almost identical to 0. So we are left with 1 over 3 to the 4, which is 1 over 81. So pi over 81. That's the exact answer for this question.